Example 3, and it's in your white packet in section 3.5. So we're checking to see if 2 is indeed one of the roots of the function by putting 2 into the little box for synthetic division. Put a 0 here, add 1 times 2 is 2. Add 3, 3 times 2 is 6. Add the negative 3 and 6 to get 3. Multiply 2 times 3 is 6. Add, you get 0. So that's good news. We do have a good root. We now know that 2 is an x-intercept. Now watch this. Since 2 is an x-intercept, I can factor this into x minus 2 times, what's the other quantity if we ended up with 133 down there? Good. X squared plus 3x plus 3. So real quick, if you put this in y equals, you would see this graph. If you put this in y equals, it's the factored version of that, you would see the same graph. Okay? We just pulled it apart into x minus 2 times that. Now, the question becomes, where are the other solutions? Where are the other x-intercepts? We learned in those videos that I wanted you to watch, we watched a couple in class, that if the degree is 3, how many x-intercepts is it supposed to have? How many solutions? How many roots? It's supposed to have 3. Only 1 is visible. It looks like it doesn't quite hit the axis there. So where are the other 2? They're in that lateral plane, that lateral world known as imaginary numbers. To find them, which you are going to be expected to do, you're going to have to run the red thing through the quadratic formula. Okay? That'll help you find the other 2 solutions. Just the red part. Since it's a quadratic with x squared, it qualifies for the quadratic formula. So, our A is 1 because of the 1x squared. Our B is 3 because of the 3x. And our C is 3. To save time for those of you watching the video, I'm going to pause it, do the quadratic formula, and you'll see the solutions. Here are the solutions, negative 3/2 plus and minus I root 3 over 2. The discriminant was negative, so we have 3 total solutions now. Now they're all present and accounted for. The degree of the function is 3. One of the solutions was 2. It worked. 2. The other solution is negative 3/2 plus I root 3 over 2. And the other one is negative 3/2 minus I root 3 over 2. Those are the 3 different values that if you plug them in to the original equation, you would get 0 as your answer. That's what it means to be a root. Stop.